Hi, everybody, and welcome to our inaugural Automotive News Shift Mobility Forum in partnership with the Consumer Technology Association, a CES 2021 partner program. My name is Steve Schmidt with Automotive News, and over the next 4 hours, Automotive News publisher Jason Stein and I will be your host and MC. We've got a terrific lineup this afternoon. We're going to talk about customers and the digitization of manufacturing. We're going to talk about electrification. We're going to talk about the future movement of goods, and we'll close with what's ahead for mobility. Our agenda today includes one-on-one conversations with executives such as Scott Kehoe, VW of America CEO and President, John Krafchick, CEO of Waymo, and Mark Fields, Senior Advisor at TPG Global and former CEO of Ford Motor Company. Let's start with our first conversation, consumers and the digitization of manufacturing. Industry 4.0 technologies like digital twins, IoT, cloud are disrupting and changing everything around the product, to the plant floor, to how companies operate their businesses. Still, at the heart of all of that change and all of that disruption are consumers. And these technologies are allowing these companies to not only plan for and understand and deliver what consumers want, but in many cases often predict and proactively deliver what consumers are expecting from their mobility solutions and their mobility journeys. We're going to start our conversation by welcoming in our panelists. Let's start with Mike McCullough, Chief Engineer of Advanced Manufacturing at Ford Motor Company. Hi, Mike. Good to see you.
Hey, Steve.
Next, Ken Obachevsky, General Manager, Automotive Vertical at NetApp.
Thanks, Steve. Great. Happy to be here.
Thank you for joining. Tara Prakriya, General Manager for Azure IoT Mobility at Microsoft. Nigel Tracy, Vice President of RTA Solutions at ETOS.
Hey,
and
Steve.
finally, hello, Nigel, how are you?
Very good, thanks.
Thanks for joining. And finally, Madison White, who leads the Connected Autonomous Vehicle Solution Strategy Group with RicardoNorthAmerica. Hi, everyone. Thanks for joining.
Good to be here.
Great.
Wonderful. We've got a great conversation lined up today, and quite frankly, I think this is a great opportunity and a great way to start today's conversation. It's really about how Industry 4.0 technologies are changing manufacturing, but I think the most important thing is why those changes are really having an impact on the consumers and what they expect. So why don't we start with that question? Maybe Tara will start with you. When you hear consumers at the heart of digital manufacturing, what does that mean? And I'd like everybody to answer that question, but Tara, maybe we start with you.
Thank you for the opportunity. It's certainly a topic I feel very passionate about. I think the opportunity to put consumers at the center of this conversation lead us to the opportunity to think about, what does cloud do for this? And here becomes the opportunity to really think about the systems of systems. All the systems that a consumer is involved with, whether it's actually services that they're taking advantage of in the vehicle, but also the services from a mobile phone, also the downstream services relating to insurance and other systems of systems and working with smart cities, et cetera. But just as importantly, it's the opportunity to think about the experience of a consumer in the vehicle itself. And what does that architecture need to be in the vehicle in order to ensure that the experiences, as you said in your introduction, are not just rich, but also updated over the lifetime of the vehicle.
So Ken, when you hear about customers at the heart of digital manufacturing, what does that mean to you and what does that mean to your organization?
Yeah, thanks, Steve. So, for those who don't know a lot about NetApp, so today we provide data storage and data management for much of the automotive industry, both for the OEMs and the tier ones in their data center. And what our unique capability is to remove data silos for our customers so they can access their data at any time, any location, whether it be in the cloud or in their data centers, in any format. And what that allows them is data agility, data mobility. And a specific example on the manufacturing side is use case is using AI on aggregated sensor data to do things like visual inspection of paint quality or weld integrity. So we see manufacturing as a key area that we're investing in to help our customers, and it really translates to the consumer because it's going to result, they're going to have much improved quality vehicles going forward.
Madison, how about from your perspective and Ricardo's role in the value chain? When the things that you do for Ricardo and advising your clients, and you hear customers at the heart of digital manufacturing, what does that mean?
So as Ricardo is a consultancy and professional services organization, our customers are actually the OEMs and the supply chain serving those OEMs. So when we hear consumer at the heart of manufacturing, that means we need to internalize the needs and desires for the end consumer, for our customers, right? So the experience demands from a passenger car owner to a military grade off-road vehicle are completely different. So for Ricardo, it's really internalizing the needs of the end consumer and doing what we can as an extension to and direct partner with the OEM to make sure that they're able to put the consumer at the heart of their vision for digitized manufacturing.
Thank you. Nigel?
So I think Tara touched on a couple of points that I think are very relevant. So when you look at automotive manufacturing today, it's about mass producing the same thing lots and lots of times. If you put the consumer at the center of it, then you're moving to a world where you're building things customized and tailored to the individual consumers. So that gives interesting challenges of how to build unique products, one for each customer, how to have that variability. And I think Tara already mentioned that the software architecture and the underlying platforms to enable that, I think, become key. How can you do that and have that variability and customization and still know the system is safe and still okay to put in operation? And then previously, cars pretty much are static after they run off the production line. The feature set is frozen today. As we move to a lot of updates post-manufacture, that extends that problem into also the domain of while the consumer's owning the vehicle. How do you continue to update it, but how do you keep it safe and solve some of those problems? So the manufacturing process, I think, no longer stops at the end of the production line. For software, at least, it goes over the lifetime of the vehicle. So this presents lots of interesting new challenges that we have to pick up and solve. And the underlying software platform, I think, is a key enabler there, as we've seen from other industries.
And finally, Mike, I think where you sit in the value chain and Ford being, a company that is manufacturing specifically for the end user and the end consumer, I'd like your perspective. And when you and the team at Ford hears this notion that says putting consumers at the heart of digital manufacturing, what does that mean for Ford and your team?
It really is a significant shift for us to go as a manufacturing organization and to embrace the role that we have and the role that we potentially can play in a lot of those same experiences that the other panelists have kind of identified, whether it's building more custom features into the vehicles that meet the customer requirements and improve people's experiences, or it's being aware of and directly connected to how the vehicles are performing in the field and the positive and less positive experiences that customers might be having, and then incorporating that into a feedback loop that we then leverage to improve our manufacturing optimization and continue to provide experiences that build trusting relationships with customers, because that is ultimately the goal. We are no longer building products to just a set of specifications. We're building products with the mindset of the individuals that will be in those products, interacting with those products, interacting with services delivered through those products. And it's just a really exciting time for us, all of us really in the automotive industry, and certainly within Ford Motor Company, we recognize the really important role that manufacturing plays in all of that.
So Mike, what you just said is actually really interesting, and I think it's probably worth underlining. And that is, I think what you just said, if you can correct me if I misheard you, is really connecting the manufacturing feedback loop then with the consumer feedback loop over the lifetime of the vehicle. That's pretty bold.
Yeah, I mean, at Ford, we've spent a lot of time and effort to provide our vehicles with the capability of communicating wirelessly and collecting information around the interactions that people are having, and really, quite honestly, things that maybe people aren't even recognizing, in taking some of that insight into how the vehicles are performing in the field, incorporate that into how we're engineering the products, subsystems, and ultimately how we manufacture those products and those subsystems, so that we can continuously improve the value of experiences that people are having. So absolutely.
Yeah,
Well,
I
it
think
actually changes. It actually changes the role of manufacturing, transforms and evolves the role of manufacturing. As I think it was brought up a few minutes ago, this notion of traditionally manufacturing is built to requirements. And now, Mike, what you're describing, I think, Tara, what you're also alluding to is you're building for the customer at this point. You're building for customer experience. You're building, not for the requirements from an engineering perspective, but you're building towards what customers expect, what they want, and even maybe in some cases anticipating what consumers want before they even know what they want. From a manufacturing perspective, how does this digitization, how is this morphing or changing the manufacturing operations altogether, Mike? And then I think from all the other panelists, I'd like a point of view that how are you enabling that, where, from a point of view of where you sit in this process?
Yeah, I mean, Ford Motor Company is not new to having completely connected manufacturing processes within our factories. And I've been with Ford Motor Company 27 years. So I've been on the journey with Ford. We've continued to update and increase the expectations of how our manufacturing processes communicate. And now when we can take that data from our manufacturing processes and aggregate it across multiple facilities and potentially extend it into our supply base, and then connect the dots to the experiences that people are having that are relative to the design or the manufacturing of those particular components or processes. It really creates an exciting series of the term we use is a digital thread that connects all the digital twins that provides us with an opportunity to really accelerate our insight into what do people really value, and then to focus our effort on improving the experiences that people are having around those values.
Absolutely. Ken?
Yeah, I think to add on to what Mike is talking about, if you think what's really exciting for the consumer going forward is that the ability to really not only connect the data from the development process to the manufacturing process, but then also to be collecting real-time data on the car. So, you think about, if you're collecting data off the car and you're feeding that back into the engineering and the manufacturing team, where you can do real predictive or preventative maintenance. And if you're able to make a real-time update to the car where you're improving fuel efficiency, imagine the consumer seeing that and seeing how they're getting real-time improvements in their car. I think that'll, really be valuable to create customer affinity. And then from the NetApp standpoint, what we can really help there is, we're experts at managing the data and moving the data. And we can, help enable the data coming from the car, moving it to the cloud, moving it back into the, as an example, into Ford's data center, where Mike talked about, where he's aggregating the data from the engineering side, from the manufacturing side. So we can help the customers, have access to that data as they need it. And then eventually the consumers can start to get some real-time feedback and see some, see their vehicle being improved as they own it through the ownership period, rather than seeing a vehicle degrade as you would normally think it would. So.
Madison, I'd like your point of view in the clients that you're advising, right? And they're at this maybe crossroads that they see these technologies and they historically, as Mike pointed out, right, many manufacturers have built towards requirements. How are you advising your clients to make the shift or think about the shift of changing to building for customer expectations?
Well, yeah, I think Mike summed it up perfectly with the digital thread. Right, or establishing a continuous digital thread from design through manufacturing and all the way through operation. And I think one thing that we should address here is we should enable not designing just to requirements, but having the consumer at the heart of design and manufacture as well, right? It's not just manufacturing that we're talking about. So from the Ricardo perspective, we're focusing on enabling continuous virtual product development. We're looking at enabling the true digital twin, not just at the component level, but a full vehicle digital twin, to remove physical builds, to decrease cost, time to market for these new features and services at the rate at which consumers are demanding today, right? And then looking at ways in which we can more efficiently, cost effectively collect data from vehicles on the road, whether they are truly connected now or they're 2020 onward that have embedded connectivity supported. So we're looking at optimized methods of data collection, so higher frequency, higher fidelity data, and targeted data, so that when we are using the data collected to make informed design decisions to improve manufacturing processes, we can reduce the amount of manual engineering analysis effort by collecting more optimized and targeted data sets.
Nigel, any perspectives?
Yeah, I think picking up on the point that Mike raised, obviously with the manufacturing, then expanding into the lifetime of the vehicle. I mean, the ETAS perspective is very much focused on the software, and what we see is there's many enablers to this being able to manufacturing not finishing with the production line, but at least for software going over the lifetime of the vehicle. And I think to enable a lot of what we've been discussing, there's key enablers. Of course, there's connectivity, there's cloud and data management, but another key part of the puzzle that we've seen from other industries like the smartphone or even the PC industry 50 years ago is you need middleware. You need platform software, what maybe is called operating systems in other environments, to enable this, to enable it to be done in a safe way. And if you're going to have this kind of continuous update, then I think you need platforms and technologies that give you the software architecture to allow this to happen. And it definitely presents some really interesting new challenges. I mean, today, mainly software in the vehicle, at least in the deeply embedded safety-related ECUs, are updated in a very controlled environment, either on the production line or sometimes in the garage. The updates are pretty infrequent in those kind of ECUs. But if we're updating them in the field and providing the consumers with the ever-increasing functionality over the lifetime of the vehicle, how to do those updates in a safe way. I mean, you don't want to start a reflashing of your embedded ECUs that's going to take maybe half an hour or so. At the point your kids are locked in the car and now your central locking system's not working because it's being updated. And how are we going to mitigate those? Because today in the production process or the manufacturing process, we do all of those things in very controlled environments. In the future, we're doing it in the field, which is an interesting challenge.
Absolutely.
Nigel, I feel compelled to interject. We've been on this journey, at least from a Microsoft perspective, for many, many years now. A lot of it with all of you in the ecosystem, and certainly with Ford through many, many cycles of innovation. Starting obviously from the Ford Sync days, but now a lot more in the cloud. That middleware platform, we certainly think at Microsoft is key. That it's an important. In fact, we'll say that the key to the future of automotive is actually the database key. In many ways. And I'm not trying to, obviously it's very important to actually have the connectivity and, some of the work that NetApps does, et cetera, for actually, moving the physical moving of the data from different places is obviously super critical. But I think Madison touched on that. You have to be targeted in terms of what you're getting. You have to know what it is. You have to have even simple things like vehicle IDs to be consistent across all the different services that are being handled. And to Mike's point, if you're going to connect the inner loop of engineering with the outer loop of production vehicles, you have to have some consistency on your metadata. Otherwise, how do you do the select statement on all the vehicles with a particular piece of hardware, whether they're in the wild or they're in your test lab? You need to have that consistency. You're going to need standards. And I think as an industry, we say digital twin, but I think we're going to have to be a little bit more deliberate about defining digital twins in terms of the connection from the design phase in manufacturing, right from SysML, all the way through to the runtime understanding of the state of the vehicle. And this is not a trivial undertaking, and it's one that's going to require a ton of cooperation, I'd say, all across the board.
Yeah, and one add here, it's not just the digital twin or the virtual representation of the software stack that's running in the car, but you have to consider the underlying hardware components as well. And when you're talking about being able to perform continuous updates of the life cycle of the car, or even have the compute power to manage mixed criticality operating systems or handle your AutoZar adaptive middleware framework on top, the hardware must be designed now to enable those updates over time, right? So.
Yep. Well, absolutely. Let's do a little level setting here. We're using digital twin, and I know there's different versions of digital twin. So I will throw it up there as a jump ball. Who wants to take it? Help our audience understand what the digital twin is, and even let's go a little bit further. What kinds of digital twins are out there?
Yeah, I can talk to on the manufacturing side. when I explain it to people internal to Ford and external to Ford, what I usually say is we're on a journey from going from a lower resolution digital twin of our processes to a very, very high resolution and very tuned version of a digital twin. So it's no secret that for many decades that the example that I usually provide is when we do clamping joints with fastening systems, we measure the torque values and the angle past yield, and there's indicators there that are captured and associated directly with every single clamp load. That is a form of digital twin, but it is a very low resolution form of a digital twin. As we evolve and really tend to shift our focus on a proper digital twin that can really give us some leverage to provide, again, a focus on meaningful experiences for consumers, a higher resolution digital twin of that might also include when was that torque gun last calibrated? What was the percent error state of that particular gun when it was calibrated? The fastener, what lot of material was the fastener from? And is there a correlation between the coatings that are on that fastener and the ability to provide the proper clamp load? And that might be like a very simple explanation of what a digital twin is, but that's all data that we collect today as a lower resolution. And the goal would be, maybe not for every single fastener, but the goal would be to increase the clarity and the resolution level and the focus of the digital twin, the data that's important to the consumer and the experiences that consumers are having, and to provide the proper sensorization and to route the data to the right place and to perform the right levels of analytics and then to drive that into the engineering factory that we have to make better engineering decisions going forward on Ford model programs.
Tara?
I think that when and where part of the question that you just brought up, Mike, is really important, and one that I think we don't really pay enough attention to, because it isn't just a question of what metadata needs to be a part of understanding not just what happened, but be used for then the simulation of what should happen. If we even think about connecting this now to autonomous vehicle development, right, where so much of the functionality of a vehicle is now software-based, not just hardware-based. And obviously everything has a software and a hardware component. It's just that mix is starting to shift a little bit. I think having that when and where component of thinking about digital twins is super, super important. But I love the question framing in terms of, what are the digital twins? There are going to be many of them, and we're going to have different twins for different pieces and different uses, but it behooves us to figure out how to string that together. And, just as an example, like I said, I think, many folks use, SysML to define vehicles in a design state. Then we want to have the current state of the vehicle as it's running. It's kind of maybe even for triggering different pieces of functionality. We'll need to have a vehicle abstraction layer so that functionality software oriented can scale across multiple vehicles, not just a single make and model in a single year in a single region, but to scale across multiple vehicles so that functionality can really start moving up the chain a little bit. And then, of course, there's how to work with an ecosystem. What is the metadata that needs to be reasonably understood so that the tier ones and the tier twos, everyone can really share data on both what's happening and what's planned and what's simulated in a reasonable fashion. That's 4 or 5 models, right there. And clearly, you can't necessarily collapse them all, but you have to have relationships, at least a few concepts that are significantly consistent across all of them. So I think middleware is super important to make all of that happen. I would love to know, how we think of this as an industry from my fellow panelists in terms of how consolidated does this need to be? Where are the standards going to come from? And is each OEM going to go figure this out on their own, or is there an opportunity to think of this in a little bit more cross-industry way?
Yeah, absolutely. I think standards and commonality, right? I kind of harkens back to Sergio Marchionne and the Tales of a Capital Junkie, where from a few years ago that says, OEMs were and suppliers were competing for a lot of the same functionality under the hood on the chassis, and the competitive part was, the top hat and everything that consumers we're seeing as well. So, let's dig into that a little bit. Are we talking about first, let's start with commonality. What is the current state of commonality and standards when we're talking about these topics of digitization of manufacturing? Madison? Sorry.
Maybe the long pause gives you some insight.
Yeah.
Yeah.
We don't know. There's still a lot of work to do.
Yeah.
Well, so I know Tara's probably familiar with this, but there's a new consortium that's been developed to bring an ecosystem of players together to define standards for what a digital twin is, right? Across the entire life cycle of the digital twin for concept design, manufacturing, operation, what have you, right? So we're looking at what is the standardized architecture of a digital twin? What is the standardized formats in which these digital twins are built? The data formats for communicating across this entire digital thread. And, from my perspective, there are standardized methodologies and tools that are being leveraged today, but I'm not sure if that we have those purely defined for that higher fidelity model that Mike has been talking about in the future.
Nigel, your perspective?
So I think my perspective is more looking at the software side of things, and there's been standardization over the last 20 years or so within the AUTOSAR consortium. First, it focused very much on the deeply embedded software and having a common platform or middleware for these hard, real-time, safety-critical, relevant ECUs. And that's been pretty successful. I would say the penetration there is by far the vast majority of ECUs today are following that AUTOSAR classic approach. In the last 4 or 5 years, it's moved to the higher end computers that we're seeing being introduced now into the new E architectures, so the kind of central vehicle computers or domain controllers that are providing a lot of this new functionality that's going into the car, the connectivity, the autonomous driving. And here the AUTOSAR initiative has again been very active with the new adaptive platform that's focused on these big, more powerful microprocessor type ECUs. So again, there's a standardization effort there. It's a lot less mature there. First ECUs following this standard are heading into production in the next 1 or 2 years, and then it'll ramp up and we'll see the penetration from there. I think the interesting thing we see right now as well is a big initiative amongst a lot of the OEMs all working on their own operating system initiatives. I mean, we see a lot of announcements here. And I think the interesting question here is, will the automotive industry really be able to sustain one operating system per OEM? Or will we see a consolidation like we've seen in most other industries? I mean, most other industries, when the value shifts to the software, 1, 2, maybe 3 platforms survive in the long run. And my suspicion is automotive will end up being similar as the value moves more and more to software, and that it won't be affordable to simply have such diversity. The cost of porting applications and moving them between different systems will simply eclipse the costs here and cause problems. So I think there's a considerable amount of standardization over the last 20 years, but I think we're going to have to see this keep going. My feeling is this OEM fragmented approach probably won't survive in the long run, just because the software costs will get too high.
Well, apart from the software costs, I would also think that there's complexities in terms of aggregating that data and getting insights from it all, right? If you're having different data from different suppliers, different softwares, different standards, that creates complexity, cost, maybe even missed opportunity to actually aggregate all that data and develop very meaningful insights around that. So what do we need to do, or what does the industry need to do to tackle that? Ken, maybe we'll start with you.
Yeah, and one thing I would kind of add, to Nigel's points as well, I think, one of the challenges the automotive industry has specifically, and, ideally you'd like to be able to take, the trends that are coming, let's say from the enterprise or the computing world, and bring that into automotive. However, you can't do it as is because you have some, you have the safety aspects that have to be looked at as well. So I think historically that's led to maybe some of these fractured architectures as well. So I think what the automotive industry really needs to be able to do is to balance that from a safety, but also be able to take advantage of the technology trends as you're putting more compute platforms in the vehicle, things like virtualization, eventually to containers as well. So the tricky part is how do you get the industry to come together? I think there's certain standards that have been successful, things like CAN, but there's others that haven't been successful, things like infotainment architectures, tried it with things like Geneva, but ultimately those weren't very successful to get the industry together. I would concur that I think AUTOSAR is certainly one where there's a lot of momentum around it. So how do we have that balance maybe for kind of the plumbing of the architecture, but done in a way where you could you could take advantage of, the new technologies that are coming down the pipe, so the automotive industry and ultimately the consumers can take advantage of that as well.
Absolutely.
Yeah.
If I could jump in here, I think one of the key factors of this whole revolution is the OEM kind of taking ownership of their software destiny, right? Which is then shifts the way the tier ones interact with the OEM, because things that they had as points of differentiation are now being controlled and dictated by the OEM. So you're looking at, you mentioned new technologies, right? We're looking at virtualization, high performance compute, time sensitive Ethernet, and then you have the introduction and the adoption of AUTOSAR adaptive within the vehicle. So standardization and OEMs not trying to focus on the really low level embedded software bits and really focusing on that application level differentiation is going to be key to help us first create these platform architectures which are interoperable across different vendors, they're certifiable, and they're reusable across makes, models, brands, right? That's going to be key to really achieving this kind of next generation connected autonomous vehicle that the whole entire industry is kind of striving towards.
Madison, I guess I have a follow-up question for you then, just given your role in working with so many different OEMs in a strategy capacity, that shift that you just, talked about, moving that software differentiation from the tier ones really to the OEMs and, the OEMs owning that software destiny. That's a non-trivial shift in approach and organization and change management. I'd love to hear what the best practices are for approaching that, not just from the point of view of the OEM, but the point of view of so many of us in the industry, Microsoft included, who work with these OEMs. And, we all have the same goal, but hard to get there.
Right. Well, I mean, you've seen this shift over time. In the last 5 or 6 years, each of the tier ones is adopting this new connected. They're not just software companies. They're not just hardware software manufacturers, but they're data companies, they're data analysts, and they are software companies combined. So I think there is a balance that needs to be achieved between developing that standardized, safe, secure platform that can be used across numerous OEMs. I mean, we're talking about tier ones rolling their own real-time operating systems and Linux distributions. That doesn't make sense. It's been done, right? So we need to find the balance between making money and delivering the value to the customers that they're actually requesting, and then helping our OEM partners find where their differentiation is as well.
Absolutely. So doesn't this change the basis of competition though? I mean, Madison, to your point that says, if the OEMs own the software structure, if I'm a supplier out there, be you on the tech side or be you a traditional supplier that is morphing its way to becoming a technology company, I'm kind of sitting in my seat and feeling a little bit nervous now with the notion of OEMs owning the software stack. So how does that change the basis of competition then within the supply base? Is it it's certainly a lot different than what we have today, and maybe I'd appreciate your point of view on that, and Mike from an OEM, but others, by all means, I'd love some opinions on that.
Yeah, I mean, I think it's a tremendous change for sure, Steve. I mean, one thing that we're seeing increasingly that didn't happen just a few years ago is the separate sourcing of software and hardware by the OEMs. Before, they would go and source an ECU to solve a functional problem for the vehicle and to provide the complete electromechanical system, the control unit, and the software. And now you're seeing more and more of the RFQs are sourcing software and hardware completely separately. And as Madison said, very often the OEMs are taking more responsibility even to create the software themselves. So not only controlling their destiny in terms of sourcing the things separately and having a tighter hand on the on how it gets developed, but even bringing it in-house, that software development. So that's a tremendous change. That's something that wasn't happening 2-3 years ago.
Mike, your point of view?
Well, this is not really a domain that I'm intimately involved in, but I think the points are very consistent. You know, on the manufacturing side, you know, we're the ones that kind of put everything together, and I do think that there is a significant shift in our understanding within manufacturing around how we properly test functionality of these subsystems as we're assembling them into vehicles, so that they could be address the specific design expectations of our customers. So I think it's becoming incredibly more complex for us certainly the content itself to create those differentiating experiences for our consumers is driving a significant amount of incremental effort to put these products in a competitive set, and then the engagement with a different type of, not just type of supplier and being software suppliers, but software in general. Development of software, as was referenced, is something that is inherently iterative. And so we end up with a lot of challenges in manufacturing to make sure that we understand, from an overall version control and into interoperability of some of the different subsystems of the vehicles, and it's increasing that complexity dramatically. And so we've had to really become fast learners around how to properly integrate the software performance in the vehicles with the traditional manufacturing metrics that we have to ensure that we're building the best quality vehicles for our consumers. So I don't really have a lot of insight into the sourcing discussions and some of the engineering discussions, but I can tell you on the factory floor, there is a significant difference in some of the challenges that we have.
I'd like to just, kind of add on to that. It is such an interesting change, I would say, all the way across. We've taken the point of view at Microsoft and in Azure that there is a real opportunity to create that middleware and to create those platforms that consolidate some of these pieces together, just to help manage the change that Mike just talked about, and the continuous changes. When you're developing for an edge and cloud that really work together, you're no longer have the opportunity or the ability to look at it as a date where you cut what the software is going to look like and that's going to stay stable and everything above that is going to somehow change. No, in this world, everything is changing all the time. You have to, just for security and for safety reasons, you have to make sure that you're always ready for all the different updates. What we find that one of the subtle changes then that occurs, both in terms of the manufacturing process and then of course the continuous operations process, is that when something goes wrong, and it will, now the playbook for how to deal with that is suddenly pretty different, because you want to really have metrics around the time to detect and the time to mitigate, and then the time to get to that root cause, not just wait for a full root cause analysis and then go ahead and make the change. You have to really detect and mitigate immediately, and that's different than the way things have been done before.
And that really drives, that high resolution digital twin and the thread that I talked about that becomes incredibly critical, so that as these software enabled experiences become more and more valued by consumers, in order to properly manage the continuous changes that are associated with software development, you have to be able to properly incorporate that into your high resolution digital twin and into your thread, and anticipate kind of what kind of impacts it might have, whether they're intended impacts or they're unintended impacts, and then be able to respond. To your point, we need to measure our response, not necessarily, I've been with Ford 27 years. We talk about 3 months in service, 6 months in service, high time in service. We need to be like in the context of, if not months in service, but maybe weeks or even days or even hours.
Yeah, and maybe Steve, one other comment I'd make too, kind of even back to the question about how does the supply base react. One thing to consider is the move to electrification happens. That's a new opportunity. I think historically a lot of investment's been made into traditional powertrain, combustion powertrains. A lot of the tier ones have expertise in that. As you move towards electrification, it's a new set of technologies. I think that also enables, changing the vehicle platform to more of a compute platform going forward. So I think that's definitely a change, and I'm sure it impacts, from development through manufacturing, obviously to the operation of the vehicle as well. So I think that's a new dynamic that's coming in the industry that will open up new opportunities and new areas where folks can differentiate as well.
So we've got about 5 minutes left, and I want to close with one question that I like to pose with each of you. And actually, Tara, you touched on it here a little bit. How is all this technology creating new business models? How is this technology creating new ways to drive revenue? If you're an OEM, if you're a supplier, if you're an insurance company, if you're a captive finance company, where are the new opportunities to drive revenue and to really engage consumers? Madison, maybe we'll start with you.
Sure. Yeah, I think first we need to touch on kind of where the industry is going with new emissions regulations. We're going towards highly automated autonomous driving. So in terms of new revenue streams or business models, just look at what's coming, right? Battery management systems, power electronics, a massive integration software services opportunity when you're talking about the consolidation of numerous software suppliers on one compute platform. So from a Ricardo perspective, an engineering service provider, there is a lot of architecture consulting, product development, virtual product development consulting, and integration work that's going on here. And then when you look at it from a consumer perspective, and we will strive to enable and produce these production scale standardized platforms, which enable all the functions within the vehicle to function as a service. And we're targeting the ability to improve vehicles over time. And this means security patches. This is, recalibration of some of the mechanical parts so that we're not bringing vehicles into service bay for fixes. So you can have new maintenance plans, predictive maintenance plans, prescriptive maintenance plans for both passenger cars and commercial fleets. You can have the ability to unlock new services and features which are actually available in the underlying software platform, but are not available to the lower grade vehicles, right? And then you're just looking at the ability to distribute new services and functions over the entire life cycle of the car. And Tara touched on this in our panel discussion or our panel prep, right? It's no longer manufacturing production done. It is looking at how we can evolve business models over the entire life cycle of the car and manage the fact that the cost is accruing because of the amount of data that we're collecting over the life cycle of the vehicle.
Absolutely. Nigel.
So I think building on what Madison already said there, you're talking about an opportunity that goes post-production over the entire life cycle of the car. I think one of the interesting challenges there is both organizational and commercial. So organizationally today, if you look at most development processes in the tier ones and at the OEMs, once something hits production, the development team's gone away. Well, that's something that has to change if we want to provide value over the lifetime of ownership of the vehicle, because you're only going to get software updates if there's still someone working on the software. So I think that's a very important aspect that organizationally will have to shift to enable these the business models and the kind of updates that Madison was talking about. I think also scale and commercial viability, or the value proposition, is another key barrier that we have to overcome. I think so far with some of the early steps where we've struggled is to find compelling value propositions for the end consumer. So to develop something that's safe and works reliably takes money. And if the uptake is very low, then the amount you have to charge to get profit on that is high. And then when you compare that to the delivery of services to your mobile phone, then somehow the costs just seem out of proportion. The only way we're going to solve that is to get scale. And that means standardization, consistent middleware, the kind of things that we've been talking about earlier. So I think to enable a lot of that, these things and these business models, these things are also key. If we don't get scale, then we won't get the price at a point where the value proposition's really adding up, and we won't get into that virtuous cycle of things growing and growing. And I think that's where we're struggling a little bit at the moment.
Absolutely. Ken, your point of view, where are new opportunities to engage consumers, new business models, et cetera?
Yeah, and I think, adding to Madison and Nigel's viewpoint, I think the automotive industry has been trying to capture new services for quite a while, but I think now is the time to really look and understand what the consumer wants. And that is related to kind of look at society today. Obviously, look at the impact that COVID-19 has had and the immediate changes it's brought. Now we're talking about a, omni-channel retail experience. Do people want to go into dealerships anymore? Well, there's opportunities on how you take advantage of that. The traditional financing models, as you move towards joint ownership, maybe people want what they get in the cloud is pay as you go. So how do you enable a pay as you go model rather than, a traditional finance the vehicle, over the lifetime of the car. So, I think there's lots of opportunities out there, but you have to really listen to what the consumers want and what they'll pay for. Figure that out. Certainly, I think, as Nigel mentioned, the smartphone market is an opportunity. Even look at Tesla, things that they've enabled, and what consumers are willing to pay for from the Tesla model as well. So I think there's opportunities there, but you really need to understand, where people find value and what they'll pay for. So.
Absolutely. Mike, point of view?
Well, I'll bring this back a little bit to my domain in manufacturing. We can talk a lot about it. Ford Motor Company has a significant amount of effort around how to create new interactions and opportunities to generate revenue through experiences with our products and with our services. But in the manufacturing domain, a lot of this is about really reducing the time and effort associated with introducing new models and allowing the manufacturing process to be much more responsive to changing consumer desires and interests and needs. And so from bringing it back to your question around where are there opportunities to leverage all of this to generate more revenue, if we can more rapidly get the products to the market that the market really values, or that individuals, I don't want to call it a market, that individuals value, then clearly we're going to put ourselves in a position where we can compete for new sources of revenue, because we'll be able to provide consumers that might otherwise look at other makes, like that company that Ken was just talking about that I haven't really heard much about. For market, I would be in a position to potentially displace some of those incumbent manufacturers, because we can provide consumers with things that they can't get from other OEMs.
Absolutely. And Tara, we'll close today's conversation with you.
Yeah, I've loved this conversation. To be perfectly frank, it's really fun to do this because we're all looking at the future, and seeing everyone's perspectives helps make all of our collective futures significantly more clear. But I think for the revenue question, I think I think Madison brought this up. I think it's really important to think about the cost, right? The cost of a vehicle is no longer the BOM cost. The cost of a vehicle is over the lifetime, because you do have to compute or actually consider the cost of that connected vehicle, the autonomous development, the continuous updates, and all of that. So now that the cost line is over the entire lifetime of a vehicle, the revenue lines have to match that. It's now no longer kind of a neat new opportunity to have digital services revenue. It's going to be necessary in order to really match where the costs are as well. So for that, I think there are three areas to look at. Speed, as Mike said, is really important. That ability to be able to have a quick twitch opportunity to match what we see consumer tastes go towards, and have very fast ways of delivering new value. Then there's the total lifetime ownership cost from a consumer point of view. I think there are a lot of opportunities there, ranging from insurance to financing, as was mentioned. And then, of course, the total cost of ownership of the fleet, which may be where some of the real value of predictive maintenance comes through. It may turn out to be a little bit more at the fleet level rather than the individual level, but the other pieces are just as important. But we're going to need new lenses, and we're going to need the opportunity to iterate and to experiment. It's we're not going to get it right the first time around, and we need to be able to keep iterating on that. And for that, I love hearing about everyone coming to the conclusion that standards and platforms are going to be necessary, and I think cooperation across our industry is going to be needed. Because safety is so important, we just can't be laissez-faire about how we experiment. We have to do so in a really concerted way, and the best way to do that is to do that together.
Tara, thank you. I have a funny feeling your topic, your mention of fleet's going to come up in a couple of hours when we have a conversation with others on movement of goods. It's a very important topic for that conversation as well. Thank you all, Tara, Nigel, Ken, Mike, Madison. Also, Madison, thanks to Ricardo for supporting today's conversation.
Of course.
Yes, thanks,
Absolutely.
Madison.
Thank you, everyone.
Thanks.
We're going to take a quick break. We'll be back in about 10 minutes with our second conversation that focuses completely on electrification. That next session will start with a one-on-one conversation between Automotive News publisher Jason Stein and VW of America CEO and President Scott Keogh. We'll be back in just a few minutes. Stick around.
Welcome to In the Driver's Seat. In the driver's seat today is Marcus McCammon, president of Ricardo's U.S. subsidiary. Marcus joined the company in 2019 and has nearly 25 years of automotive industry experience, including product development, manufacturing, brand leadership, and marketing experience. Hi, Marcus. How are you?
Good, Jason. How you doing?
Good. Tell us, first of all, where are you and what's that behind you?
So I'm in our offices in Southern California. So we're just north of San Diego. And behind me is our autonomous test vehicle. So this is where our software and electrification teams sit. And this is a prototype autonomous development vehicle that we have.
Next time I'm in SoCal, you have to give me a ride in it.
You got it.
We're going to talk manufacturing transformation today. And Marcus, you're in a very unique position with all of the experience. Industry-wide, how do you see design, engineering, and manufacturing processes transforming over the next few years?
Yeah, that's a good question, Jason. So I think what we're going to see is, historically the development life cycle has been compartmentalized, right? You have advanced concept and you move to production design. From there, there's another handoff that happens manufacturing. We move to the sales floor. And then frankly, after the vehicles are sold, we lose sight of them. They go into a secondary market. What we're going to see is a continuation of that loop. So the design life cycle is going to become more continuous, where we are feeding data from vehicles that are sold in the field back to the design process in real time, such that each iteration of the vehicle becomes that much more robust and the design process happens faster.
So Marcus, when it comes to bringing some of that new technology to scale, which of course we know is so important in this business, from the engineering and design offices to the factory floor, how does Ricardo fit into that? And what kinds of conversations are you having with your customers?
Yeah, so Ricardo has been at the helm of advanced design for the 105 years that it's been in existence. So generally speaking, we engage with our customers when they're trying to innovate new concepts. We help them in the development of those concepts, moving them forward to a production-ready design, and in some cases to low-volume production. Today, we're also providing the software, some of the software tools that fit into the ecosystem to help make that design process more robust. And then we're helping them with the simulation, the data collection, and the methodologies to have that continuous loop of the design life cycle be more integrated.
I would imagine that you would absolutely concur that software is the new space in the auto industry these days.
Yeah, absolutely. It's been interesting for me. I mean, I started my career in automotive in Detroit, right? I was at what is now FCA. And then just before coming to Ricardo, I was with a subsidiary of Intel. And what I've seen is that the kind of fast to fail, rapid innovation model of Silicon Valley has really come into a collision, frankly, with the process to perfection model that we knew in Detroit. And the future for the industry is to see something in between, where we bridge between that speed of innovation and that process and that robustness that we've come to develop in the automotive industry.
So let's talk electrification. It's on everyone's mind these days. We're weeks away from a new administration. Of course, in the US, they are proposing an aggressive $2 trillion climate plan that's going to include tax credits and for EVs and additional charging stations nationwide. You look at the stock price of Tesla and other EV companies continuing to just blast through the roof. Give me your perspective on where the industry is when it comes to electrification and where we're headed.
Yeah, I think what we see in the stock market is a proxy for the overall changes happening in the auto industry, right? So, I'll give Tesla some good credit for one thing in particular. This notion of this new connected life cycle, Tesla is really a prototype for it. And what the market is really giving Tesla credit for is the overall change of the industry, more so than it is just electrification. The integration of software, the fact that you can collect data in real time, the fact that you can change the experience of the vehicle while it's still in the possession of the consumer. If you see the most recent announcements from Ford Motor Company, Jim Farley is talking about where the new Mustang Mach-E is going to have the ability to be updated even before you take ownership of the first vehicle, and how they have planned updates to come continuously. That is part and parcel to what we see as the electrification of the industry. It's much broader than just electrification. And those policies that we see coming with the new administration are really reflective of the same tone that we see happening around the globe. The world has come into grips with the notion that we have to do something to address climate change. Electrification is a key factor in that path forward. Now, that doesn't mean that all internal combustion engines are going to go away, but definitely the market is hedging itself towards this new, more connected, more innovative future.
So we got a ton of transformation. You've seen a ton of transformation in your 25 years in the industry. How do we position the industry to come out stronger on the other side?
Yeah, that's a great question, because the reality is the industry is trying to figure out a way to not lose the strength that we've developed over the past century and a half in conventional automotive, but embrace the speed of innovation that the tech sector has. And I think the way that we do that is by, it's really kind of this technology and exchange, right? We have to bring the two cultures together, and we have to establish a platform kind of thinking where the conventional industry puts their money and their investment in the places where incremental value can be created for the end consumer, and not try to reinvent the wheel every time we innovate for a new product. So Ricardo is trying to be a vehicle for that transformation. We're helping with the development of open standards for autonomous driving. We're aligned with some standard-based approaches and model-based development for electric vehicles, as well as finding new and innovative ways to get more efficiency out of some of our legacy technologies as well.
And since we have you, and since you're sitting in front of an autonomous vehicle, I'm curious, just your thoughts. A lot of talk over the course of the last year as we battle through COVID now about investing in autonomous technology. What's your current view?
Well, to me, autonomous vehicles and automated technology is a long game, right? At the end of the day, what we're solving for is the ability to make vehicles safer for consumers and help them to use the vehicle as a broader extension of their life cycle. It's not something that we can rush. And frankly, the notion that we can all kind of leapfrog our way into that large of a transformation where we relinquish control of the vehicle is a little bit too aggressive. And I can say that having been a part of it, on both the automotive side and the tech side for the past 6 or 7 years. What we do need to do, though, is continue the development in a very measured and calculated fashion. And again, find ways where we can focus the innovation on things that will have incremental value for the consumer, and the places where there is repeatability and reuse that can be used broadly across the industry and reduce the risk across the industry, we need to collaborate more. And I think we're seeing that trend happening across the industry now.
Marcus, really appreciate you being with us. We have a bit of a tradition here on In the Driver's Seat, a 0 to 60 challenge. And over the next 60 seconds, we'd like you to give our viewers a bit of a glimpse into who you are. We want to get to know you a little bit better. So we're going to throw you a couple curveballs that I'm sure you're going to hit out of the park. But you ready for the challenge?
I'll take it.
All right. What was your first car, Marcus?
My first car was an M-body Chrysler. So a Chrysler Fifth Avenue, brown, and all the paint was faded off of it.
That was a classy ride.
Yeah, fine Corinthian leather, right?
Fine Corinthian leather, exactly. Ricardo Montalban. What's your own comfort food?
My comfort food is pizza. It's a perfect food. All the major food groups incorporated in one fine piece of artistry.
I love it. What movie could you watch over and over again?
Gone in 60 Seconds.
Shelby
GT 500 is my favorite car.
What's a trip that changed you and why?
Trip that changed me, probably my first time going to Romania, because what it helped me to understand is we have perceptions of kind of what the rest of the world looks like. And I saw some of the most innovative minds I could have imagined in a town that I would have never even thought to register with. Yeah.
Excellent. Final one to close it out. If you were a ball player, what would your walk-up song be?
Ooh, that's challenging. Probably.
We've heard a lot of previous guests. AC/DC has been a hot topic. But
AC/DC. I'd probably have to go with like Run DMC, right? I'm a New York City kid, so it'd have to be something from Run DMC, I think.
I love it. Marcus, thanks so much for being in the driver's seat.
All right, thank you guys.